Beneath Yellowstone's geysers and hot springs, a vast volcanic system holds secrets that scientists are still uncovering. A new study has mapped hidden magma reservoirs, refining what we know about the park's underground heat. One region stands out, showing signs of long-term molten activity. While there's no imminent danger, the findings shift the conversation on Yellowstone's volcanic future. Yellowstone National Park, located primarily in northwestern Wyoming and extending into Montana and Idaho, is home to one of the world's most studied volcanic systems. This system has drawn the attention of geologists due to its dynamic nature and its history of supervolcanic eruptions. Recent research by the U.S. Geological Survey, USGS, and Oregon State University has provided a more detailed understanding of the magma reservoirs beneath the park. A study led by geophysicist Ninfa Bennington used magnetotelluric measurements to image the subsurface, revealing 4 distinct magma bodies beneath Yellowstone. Among these, the northeastern magma body appears to retain sufficient heat to remain partially molten over the long term, making it the most likely candidate for any potential future volcanic activity. Yellowstone's history of massive eruptions. Yellowstone has experienced 3 major eruptions over the past 2.1 million years, each leaving behind a caldera, a massive volcanic depression formed when magma is expelled, causing the ground above to collapse. These eruptions formed what is now known as the Yellowstone caldera, measuring approximately 30 by 45 miles, 48 by 72 kilometers. The last of these supereruptions, the Lava Creek eruption approximately 631,000 years ago, left a landscape marked by geothermal activity, including geysers, fumaroles, and hot springs. These features are surface expressions of the vast heat reservoir beneath the park. Scientists continue to analyze these geothermal regions to track changes in subsurface conditions. Mapping magma deep underground, the research team employed magnetotelluric instruments to detect variations in electrical conductivity underground, allowing them to map the distribution of molten rock beneath Yellowstone without drilling. Their findings indicate that rhyolitic melts are stored in segregated regions beneath the caldera, suggesting that magma is not evenly distributed but rather concentrated in specific areas. The northeastern magma body, located beneath the northeastern section of the Yellowstone caldera, was identified as the only reservoir with long-term heat retention, making it a focal point for future monitoring efforts. A schematic map of Yellowstone's volcanic structure highlights several key geothermal areas: Lower Geyser Basin, LGB, Norris Geyser Basin, NGB, Hot Springs Basin, HSB. These basins are surface indicators of the heat below and align with the mapped locations of magma reservoirs. The northeastern magma body, while the presence of 4 distinct magma bodies was confirmed, only the northeastern sector appears to retain enough heat to remain partially molten long-term. This refines previous models that considered multiple regions as potential future eruption sites.